Hello everyone. Today I'll be solving this question. This came in GATE 2016 exam. I'll read the question. In the question, a two-dimensional square rigid box is given to us, and this box contains 6 non-interacting electrons. And we need to find out the ground state energy of this system of electrons. So it is given to us a two-dimensional rigid box, right? And we know that when there is a particle in one-dimensional box, we know the energy and wave function form of a particle that is inside a 1D box. So energy is given by n square pi square h cross square upon 2ma square. N is energy level and a is the width of this box. Similarly, wave function is given by under root 2 upon a sine n pi x by a. Okay, these are the energy level and wave function of a particle that is placed inside a 1D box. This is 1D system. This is 1D system, and in the question we are given 2D system. Okay, so the general Schrodinger equation for this will be, we know the general, minus h cross square upon 2m d2 psi by dx square d2 psi by dy square psi x y plus v this is not z e psi xy. So this is the general solution of general form of Schrodinger equation for a 2D system. Now solving this equation in the same way just like we solve for one dimension system. So what we will get? Minus h cross square upon 2m. Okay, d2 psi by dx square I'm again writing the whole equation here. So when this potential and the probability of finding the particle is independent of time and depends only on position, so we can write this psi wave function, not z, is the multiplicative of individual wave function, and energy xy will be additive. Okay, and we can use this variable separation method to solve this equation. So what you will get? You will get this type of equation. Ax psi x For x direction, and d2 psi by d y square v psi y e y psi y for y direction. And you know, this is this is the equation for particle in the 1D box. And we know how to solve this equation, and we know the energy levels and wave function form for this equation, for this Schrodinger equation. Now for x direction, the energy will be Ex is equals to nx square pi square h cross square upon 2ma square. This is the level along x. And for y, same, ny square pi square h cross square upon 2ma square. And I already told you, like, energy will be additive function, Ex plus Ey. Pi square h cross square upon 2ma square. And the wave function will be multiplicative function, root 2 upon a. Since it is a square, so length and breadth will be same. I am taking it as a. This is first function. This is sine ny pi y by a. This is wave function form. Now coming back to the question, is nx square ny square pi square h cross square upon 2ma square, right? So there are 6 non-interacting electrons, and they are placed. We need to find out the ground state energy. So now we'll use Pauli exclusion principle. So this is first level, this is second level. Okay. Now nx and ny value. So first state, 0 0 we cannot take, otherwise the energy will become 0, and the probability of if delta is going to 0, that means delta p is also going to 0. So what will be delta x? It will be infinite. So this is not possible. This will not be the case. So what will be the case of nx and ny? The ground state, 1 1. Okay. So this will be the ground state, 1 1. Now coming back to the second state, that is nx is equals to 1, ny is equals to 2. But I can also write it as nx is equals to 2 and ny is equals to 1. This means there is a degeneracy for this level. And what do you mean by degeneracy? Degeneracy means group of state having same energy, state having same energy levels, or you can say same energy value. Okay, we can see here that if you put nx is equals to 1, ny is equals to 2, you will get same energy as nx is equals to 2, ny is equals to 1. So there is 1 1, and for this one I have two combination, nx and ny. Okay. Now there are 6 electrons, and from Pauli exclusion principle, no two electron can have same quantum states. So 2 electrons will come here, 2 will go to this state, 2 1, and 2 will go for this state, 1 2. So how many electrons? What will be the energy in terms of pi square h cross square upon 2ma square? First we will go for this one, 1 1. When nx value is 1, ny value is 1, so there are 2 electrons. Okay, 1 plus 1. And how many electrons are there with nx value as 2? There are 2 electrons, right? 1 2. Now when nx is equals to 2 square, ny is equals to 1, then how many electrons are there? There are 2 electrons. Again, when nx is 1 and ny is equals to 2, how many electrons are there? 2. Solve it. We'll get ground state energy. Pi square h cross square upon 2ma square. 2 into 2, 4. Pi square h cross square upon 2ma square. This is 5. 5 into 2. Again pi square h cross square upon 2ma square. This is 5 into 2. So pi square h cross square upon 2ma square. 4 into 10. 4 plus 10 plus 10 is equals to 24. Since this pi square h cross square upon 2ma square is already given in the question, so the answer is 24. The answer will be 24. I have taken A, but in the question it is given L. So this is mistake from my side. It will be L. The dimension is L. Okay. So the answer is 24. Thank you.